find the derivative of y equals x times secant inverse of x to the third power. All right, so we do see this secant inverse, right? So that's the inverse secant function, but there's also an x here, right? X times. So what does that mean? We're going to have to use the product rule here, right? And then we're going to have to take the derivative of an inverse trigonometric function, in this case secant inverse, right? Well, let's just write down what the derivative, right, of that secant inverse function is. So let's say secant inverse. I want to put u here, right, because that is the inner function here. Okay, of course, we want to make sure, okay, that we use a chain rule properly on this guy. So actually, I should just put y equals here, right? Not y equals, and then the derivative of that, right? That is going to be 1 over the absolute value of u, okay, times radical u squared minus 1 times du dx. This is the times here, right? And of course, what we're assuming is that absolute value of u is greater than 1, right? So this quantity, right, x cubed, whatever it is going to be bigger than 1. All right, now, once again, we do have to use a chain product rule here, right? Because we have these two terms that are being multiplied together. So, let's see. We have these two functions, f times g, right? What does the product rule say? That y prime is going to be, well, f prime of g times g plus g prime times f, right? And we have these two functions here that we are dealing with. So what do we get? Well, using the product rule, the derivative of x is just 1, so we get dy dx, which equals the secant inverse of x cubed. Okay, so f prime, right, this is f and g, so f prime g plus g prime, right? So we got to find the derivative of, in this case, the secant inverse of x cubed, and the formula for that is right here, right? So what do we get? We get 1 over, well, wait a minute, what is u in this case? Right, remember u in this case is x cubed, so we get 1 over x cubed, the absolute value of that. Okay. Now I get some questions, do we need to leave this as an absolute value? And the answer is yes, right? Because the cubed, okay, in case x is negative, right, well, it could still be negative, right? So we should leave that. Radical what? U squared, right? So that's going to be x to the 6 minus 1. Okay. All of that times what? Times dy dx. So in this case, du dx, right? So u is equal to x cubed, so du we know is equal to 3x squared, so times 3x squared, right? Okay. But you got to remember one thing, right? We are doing the product rule here, so g prime times this last x here. Okay. Now we can do this work on the side, I guess. Okay. Notice what happens here. We get an x cubed on the numerator. We have an x cubed here in the denominator, so regardless, it doesn't matter, right? Those will cancel out. Doesn't matter if you're positive or negative or not, right? Those will cancel out. So really, what are we left with? We're left with 3 over radical x to the 6 minus 1. So that is what we get here for the second term, right? The 3 over radical x to the 6 minus 1. And in this case, there's really nothing else for us to do. This is going to be our derivative.